Hello students, good afternoon once again and welcome to ELE 2314, Principles of Machine and Power. Okay, today experiment, actually we are now in laboratory number 9 and today experiment is all about the direct current motors, part 1. Okay, so the main objective of this experiment is to examine the construction of the DC motor generator, to measure the resistance of its windings, to study the nominal current capabilities of the various windings. Okay, now, so equipment required are, you need to have a power supply, okay, a DC voltmeter ammeter, because since we are measuring or having an experiment with regards to DC motor, so we need a DC motor as well, and some connection wires and leads. Okay, so now step number 1 will be examine the construction of DC motor generator. Okay, paying particular the attention to the motor, rheostat, connection terminals, and wiring. Note that the motor housing has been designed to allow you to view the internal construction. Most commercial motors do not have this open construction. Okay, so you need to viewing the motor for the step 2 from the rear of the module. Identify the armature windings, identify the stator poles, and how many stator poles are there. Okay, so all right, so let's have a quick view of the DC motor generator. So this is a DC motor generator, and these are the connections. Okay, so we have two windings here. We have some series and shunt windings. Okay, all right, so we have the field rheostat as well here, and the motor rating is here, no? Okay, so these are the motor ratings, and these are the generator rating, no? So this DC motor can actually do as a generator and as a motor. Okay, so let us go inside. Okay, I will take you a peek, no, with what is inside of this DC motor generator. So here's what's inside of the DC motor generator. Okay, try to examine, try to check what is inside. Okay, and identify the parts. All right. Okay, so let's close it. All right. Okay. Students, no, after you are viewing the DC motor generator, no, the construction inside, so let us connect now figure 2-1. Okay, figure 2-1. So in this figure or in this circuit, so we need to have a DC power supply, a DC power generator or DC motor or generator, and the voltage ammeter in DC. Okay, so we only need 3 modules, no? So here you will now measure the resistance of each motor windings using a voltmeter ammeter. Okay, with this information you will calculate the power losses for each of the windings using your power supply. Okay, this is the one, power supply, the DC voltmeter ammeter, and the DC motor generator. Okay, so let us connect the circuit. All right, so first connect 7, okay, to the ammeter DC, and from the ammeter DC connect it to number 5. All right, and connect number 6 of the DC motor generator to the neutral. Okay, once done, then connect the number 5 to the 400 volts and number 6 to the negative of the DC voltmeter. Alright, so what you need to do is that to turn on the power supply, okay, turn on the power supply and slowly increase this knob, okay, until your current here reaches to 300 milliamps or 0.3 amperes. Okay, so increase. Okay, that's it. Alright, so let us try to record. Please get ready your pen. Alright, so that is the voltmeter on the left side and the ammeter to the right side. Okay, that is 0.3 ampere or 300 milliamps, and the other one may be about 240, 230 or something. Okay, right? Just read it. Okay. All right. Okay. So now let us return the voltage to 0. Okay, so return the voltage to 0 and turn off the power supply. Okay. So calculate the resistance of the shunt field. Alright. So resistance equation, our shunt field is equal to E, or the voltage, divided by I. Okay. Our E is 200 plus volts and the current is 300 milliamp or 0.3 amperes. Okay. Then calculate the power, no? I squared times resistance, or R. Okay. So next thing you need to do, connect the circuit shown in figure 2-2. Okay. So connect the circuit shown in figure 2-2. So okay, all right. So all you need to do is to reconnect this, put it into the 4, and here put it in number 3. Okay, for this series connection. All right. So this is the same figure 2-1. But you need to do, just connect it above, no? So turn on the power supply, increase the DC voltage until series field carrying 1.5 ampere. Alright? Alright, now, alright, so now need to replace this, put this one, not this 300 milliamp, reconnect it, connect it to the 1.5. And this one to here. Alright. Okay, like that. Okay, so let us switch on. Okay, turn on the power supply, slowly increase the voltage until the series winding carrying 1.5 ampere of current as indicated by the DC meter. Alright. Okay, so increase. Okay, you need to 1.5, no? It needs only a little bit voltage, no, to do it. Okay, so not too much. Right, so measure and record the voltage across the series winding. Alright, so record. Okay, the voltage is very small, no? It requires only less, no, very less voltage, and the current is about 1.5. Okay, once done. Okay, once done. Put it back to 0. Okay, and switch off. Okay, so now calculate the R. Okay, resistance in the series field and the power as well. Okay, follow the manual. Next, number 9. Connect the circuit shown in 2-3. So, okay, 2-3. Alright, so what you need to do is that, okay, remove this. Okay, put it into number 2. Okay, this one to number 1. Alright, keep the ammeter at 1.5 and put this one to 40 volts. Okay, right, it's almost the same circuit, but you just modified it a little bit. Alright, so turn on the power supply. Okay, until the armature winding carry 1.5 ampere of current. Okay, so slowly increase until this will carry up to 1.5 ampere. Okay, all right. So let us move this one here, no? 400. Okay. Okay, increase this until it will get you. Okay. So get the reading for this, okay, automatically. All right. So get the readings. Okay. Here are the readings, no? And then get the resistance and also the power using the formulas. Okay. Okay, this time we use the 400 volts, not 40 volts, okay? So that's it. No? That is for experiment number 9. Okay? Thank you. Good luck.